Hello, friends. So, today I'm going to try to give you a brief overview of Agentic AI and its emerging role in clinical workflows. I'm going to basically compress this into 10-15 minutes, the theoretical concepts part. Okay, so the first thing that we want to discuss is what is the difference between a chatbot and an AI agent. So for this, we need to understand what are the characteristics of a chatbot and what are the characteristics of an AI agent. So a chatbot is primarily if you make an API call to an LLM like GPT. So using OpenAI API, if you make an LLM call, and if you ask at a question like who is the winner of Australian Open 2026, then the answer that you are going to get will not be very accurate. You'll be surprised by that. And this is because a chatbot is going to answer from its internal knowledge base or from its training knowledge. And the training data cutoff date for the latest GPT models is somewhere in 2025. So the model will probably say that this is a future date. It doesn't know that we are currently in May 2026. So that is like one characteristic of a chatbot. It is stateless. That is, you ask it one question, it gives you one response. It doesn't store any context, like it doesn't remember anything from like the previous turns, right? And you as the user have to drive the chatbot at every step. And the chatbot cannot take actions, that is, it cannot affect the external world. So these are the characteristics of uh, pure LLM or a chatbot in a traditional sense, whereas an AI agent, can interact with the external world. So if you ask the same question to ChatGPT or Google Gemini, then what it will do, it will realize that it doesn't have that knowledge in its internal knowledge base. So it will go and do a web search. So this web search is a tool that is made available to this LLM, right? So it will act on this tool, it will fetch the information and use that information to answer your question. It will correctly answer the question. So this is agentic behavior. So one characteristic of an AI agent is the LLM or large language model is central to it. So it is the LLM that is acting as the brain or the reasoning engine of the agent, right? So it is the LLM that is basically doing entire reasoning and then deciding what action to take, right? You as the user don't need to give explicit step instructions to the AI agent. The second characteristic of an AI agent is its ability to use tools. So tools are mechanisms through which the agent interacts with the external world. For example, web search can be a tool. An agent can access external database and retrieve data. That is another example. An agent uh, can call other AI models through use of API calls. That is another tool use example. An agent can write code and execute code to perform certain things. That is another example of tool use. The tool use is another characteristic of AI agent. Third one is memory. So an AI agent basically retains context through multiple turns. So if you interact with ChatGPT or Google Gemini, right? You ask it a question, it responds, and then top of it, you ask another question, right? maybe it will execute some tool like a web search, and then it will respond. So each question is a turn, and like you're asking a question, you're getting a response in between, like it is executing some tool. So this is a multi-turn conversation. So the agent is able to retain state across these turns, right? So now if you start a new chat session, you would have seen that the agent or chat GPT or Google Gemini would forget everything from the previous session. That is because like all this state is maintained in a session state, and it gets wiped off as soon as you create a new chat session. So another kind of memory that an agent has is a long-term memory. So another thing that you would have noticed is as you interact with Chat GPT or Google Gemini, it starts to remember a lot of things about you, right? It knows your preferences, right? Things you are working on. That is because an agent, as it processes your request, so if it encounters or if it discovers a certain insights, certain facts about you or about the task that it is supposed to complete, then it might save those insights or facts in an external data store so that they will come in handy in a later session. So that is long-term memory for an agent. And the fourth characteristic of an AI agent is multi-step planning. So whenever you give an AI agent a task, the first thing it does is it decomposes that task basically into a series of steps that it needs to perform. And it can execute those steps either sequentially or in parallel. But this planning phase, that is a key characteristic of an AI agent, right? That distinguishes it from a traditional chatbot. Okay, so now we come to the underlying principle on which most of these AI agents work. And that principle is known as the React framework. So React stands for reasoning, acting, and observing. So there are three stages in which an AI agent uh, basically performs its actions, right? So let us understand each of these three in detail. So when you give an AI agent task, the first thing it does is basically it observes its current state. What data does it have? What is the current environment? Where does it currently stand, and where does it need to go? What does it need to achieve? And then it has got a set of tools available with it. So basically, it performs reasoning, logical reasoning, right? That based on this current state, what is the next best immediate action to take if I want to reach the end goal? That is the reasoning part. And based on the reasoning, it performs a certain action, right? And this action is usually a tool call. So maybe it decides that it needs to retrieve data from an external database. So it will perform a tool call, and then the tool execution results of basically the retrieved records are then fed back again into the reasoning loop. So it goes back again into the observation state. So it realizes that it has now fetched the data, and then the reasoning step is triggered again. So it evaluates the retrieved data and then decides on the next best action to take. So we'll take a look at this React loop this planning and this thinking and tool execution in detail when we look at the practical agent demonstration. So this is basically the React agent architecture. React reasoning, observing, action. So these three steps execute in a loop and keep on executing till the agent meets his objective, right? So we will now take a look at a real world agent example. So for this, we will consider a medical assistant agent. And the scenario is this, that a patient comes to a doctor's office with a large number of medical records spread over multiple years. They don't understand medical terminology, nor does the caregiver. And basically, the question is, has the kidney function or renal function of the patient been getting worse over the years? So, to answer this question accurately, you need to retrieve the relevant data, basically create an data like over the last several years of lab reports, and then you need to establish a trend. And once that trend is established, then the doctor or the specialist can answer the, the the question clinically in an accurate manner. So this is the problem description, right? So how will a real world medical assistant, agentic medical assistant work in this scenario, right? So enter Swasthya Sahayak, which is a real world medical assistant or a real world agentic medical assistant, where we perform this exact task, right? So in Swasthya Sahayak, basically what we have is we have multi-agent medical chat workflow. So we have a multi-agent medical chat functionality. So as we discussed earlier about how does an agent work, so for this specific scenario, how will this multi-agent uh, chat functionality actually work under the hood, right? So you have a user's question. So let's say the user question is, for the last over the last 2 years, what is the trend of my HB1AC, or how is my kidney profile looking? Something of that sort. So this is the user query. And in this multi-agent architecture, we are using a supervisor worker architecture, wherein we have a supervisor, which, as the name suggests, is the orchestrator, main orchestrator agent, right? And under this supervisor, we have multiple specialist workers. One is the retrieval worker, whose job is to retrieve medical records from the database. Second is a clinical worker, which uses a specialist medical model, MedGemma 4B, right, for answering questions related to allopathic treatment. Another is homeopathic worker, which answers homeopathic queries. And then we have the Ayurveda workers, which answers Ayurveda related questions. And then we have a clinical brief synthesis step that the supervisor uses. So let us understand the workflow. So the question comes about the HbA1c trend, right? Now, if you ask this question to a plain chatbot like ChatGPT or Google Gemini, it cannot answer this question because it doesn't have access to your data. Now, even if you basically tell it, okay, my data is present in so and so database, it won't be able to access that data because it doesn't have access to those tools that are required to retrieve data from that specific database, right? So that is where these chatbots will fail in this specific scenario. So the supervisor agent, once this query comes in, is going, the first thing it will do is it will evaluate whether it has the necessary evidence to answer this question. So it will realize, okay, no evidence is available, then it is going to delegate the retrieval task to the retrieval worker. The retrieval worker now will interpret the query and realize that it needs at least 2 years of medical records, specifically HbA1c lab reports. So what it will do, it will call a search planner that will generate search criteria, right? And the retrieval worker is going to use this search criteria to retrieve records, specific records that are relevant to answer this specific query. The retrieved records are then made available to the supervisor agent, who again basically evaluates, right? And now this is again the reasoning part. So we are seeing the React loop in action. So the first thing was supervisor did some reasoning and then took an action, delegation to retrieval worker. Retrieval worker then basically did an action and then uh, basically made the records available to supervisor. So this was the action part. Then again, supervisor is basically reasoning about the retrieved records, and then it realizes, okay, now I have sufficient evidence available. So now triggers the second step that is done by the supervisor itself. So what it does is it prepares a structured clinical brief, right? A structured clinical brief is something like this, where like the retrieved medical records, you extract relevant information from the retrieved medical records, right? That are relevant for the specialist medical model to be able to accurately answer the question. So you filter out the noise. The medical records contain a lot of unrelated facts that are not relevant for to answer this question. So this clinical brief synthesis step is basically getting the information in a structured way so that like the specialist model gets the highest signal data. So as you can see in this particular section, we are explicitly like mentioning what the trend is over like the several lab reports over the last 2 years. So all of this data is synthesized and is made available to the clinical worker by the supervisor. So this clinical worker is the specialist MedGemma model that on the basis of this synthesized clinical brief is able to answer the question accurately. So this is basically the answer that MedGemma generates. It tells that your trend has been worsening over the years because it has got very clear evidence now available. It also is able to cite based on what medical records does it deduce this fact, right? So this is basically fact citation that makes the answer a lot more trustworthy, right? So you are citing the facts at the bottom, and also you are making inline evidence available. So you can see lab 1, lab 2. The user can go ahead and click on these links and see uh, this information is coming from which specific medical record. So this inline evidence citation is making the answer a lot more safer and trustworthy. So this is something that this multi-agent like chat assistant is performing all of this task, which normal chatbot cannot do, right? And you can also see that in this chat function, you have this clinical brief used link. We can expand on that. Once you expand on this, you can see exactly what clinical context the agent used to answer this question. So this again increases the explainability, right? Which is very important in high risk scenarios like healthcare. You need to be able to understand exactly on what basis are we producing, is the agent producing this answer. So this is where like it satisfies these key things. uh, the agentic behavior is satisfying these key things. I think we have probably exceeded the allotted time for this explanation. So I'll continue in another video about the other aspects of agentic AI in healthcare.